So this video is about definite integration. In a previous video, I discussed what indefinite integration was. That one leaves you with a plus c at the end of your expression. But here, when we have values on our integral, we have a 0 and we have a 2 on our integral symbol. That's going to result in an actual value here. We are going to get a number that's going to be the answer to this problem. So because it's integration, we're still going to integrate as we did before. So 2x to the third is going to become 2x to the fourth over 4. 4x to the first is going to be 4x squared over 2. And 5 is really 5x to the 0 here, if it helps you. Remember that's x to the 0, so this is going to be 5x. Now, instead of writing plus c right here, we're going to instead put a little bar here, and we're going to put from 0 to 2. Now, we're going to actually evaluate what this expression is when we plug in the 2, and when we plug in the 0, and when we subtract those two values. So let's write it down here. We're going to have one expression minus another expression, and that's going to equal this value. In this first expression, we are going to plug in the 2, and in the second expression, we're going to plug in the 0. So we're going to do this again. 2 something to the fourth over 4 minus 4 something to the second over 2, and then here plus 5 times something in there. And the somethings are going to be this 2, so he's going to get plugged in there, there, and there. And then the 0 is going to get plugged in here, here, and here. So now we just calculate this expression. This is 2 to the fourth power, that's 16. 16 multiplied by 2 is 32, divided by 4 is 32 over 4, minus, this is going to be 2 times 2 is 4, 4 times 4 is 16, that's going to be 16 over 2 plus 10. Now here we're going to have, these all have zeros in them, so they're all going to become 0 minus 0 plus 0, which is going to be minus 0. So this was a 10 here. So that leaves us with 8 minus 8 plus 10, which leaves us with a final answer here of 0 plus 10, which is 10. So that means this value, or the expression, the expression within this integral from 0 to 2 equals 10. Now, a number of you have a calculator which will actually do this same process. It won't show all the work, and the work is necessary for your understanding and for getting full marks on anything that you do. However, it's just helpful to know that you do have a button on your calculator that looks something like this, and I believe it has a box or something right there with a dx at the end. So all you need to do there to get this same answer, or to check your answer, is just put in your 0 to 2 and 2x to the third minus 4x plus 5, and that'll produce the same 10 if you wanted to do it on your calculator. Okay, let's consider another one here. This is the same integration, but at this point we have from a to 2, and then it equals a particular value. So instead of having to find this value, they give it to us and we need to find a. So same idea, it's just going to be slightly different solving. So we're going to integrate, so our 3x to the first is going to be 3x squared. And that's really all we have right there. So we can go directly to considering it from a to 2. And this whole process is supposed to equal 5.25. So, as in the last problem, we're going to have 3 something squared over 2 minus, you don't really need these big ones, but I put them in the last problem, so I'll put them here, and maybe that will help you see what's going on. Same thing again, and this is all going to equal 5.25. Equaling 5.25 here because of what we have up here in the original problem. So now we take our 2, we plug him in there, we take our a, and we plug him in there. So when we simplify here, this is 2 squared, which is 4, times 3 is 12, divided by 2 is going to make 6, minus, now this guy is not going to really simplify because he's a variable, but we'll leave us with this equation. Now this is just simply algebraic solving. So if I move the 6 over to this side, it's going to leave me with minus 3a squared over 2 equals 5.25 minus 6, which is going to leave us with minus 0.75 or negative 0.75. So from here, I'm going to multiply this by 2 to get rid of that and divide by negative 3. So multiplying by 2 and dividing by negative 3, multiplying by 2 is going to give me negative 1.5. Dividing by 3 is going to give me 0.5 right there. So now we'll come up here a little ways. And now we have a is going to equal, when we square root both sides, the square root of 0.5. And you can calculate that on the decimal, or we can just leave it as it is right there. Alright, finally, we have this one, the integral from 3 to 6 of the derivative. Now, again, if you remember in a previous video, we discussed that the integral of the derivative equals the original function. So in this particular case, what do we have? We have the integral of the derivative here is going to equal f of x, but since we have, let me just put them on here, since we have a 3 to 6, that means over here we're going to have a 3 to 6, or if I want to write it again down here, 3 to 6. So when you integrate the derivative, it gives you the original. If it's from 3 to 6, we're going to put 3 to 6 here. And this question asks us, what does that equal? We have a couple of different options. Well, we're not doing anything different than we've done in the previous two problems. We write two expressions with a minus in the middle. We put f of something minus f of something. And what are those somethings? The first value that gets plugged in is 6. The second value that gets plugged in is 3. And so if we look at our options we have over here, it looks like letter B is what we want to go for. So that's what we get when we talk in general terms of the integral of the derivative.